All right, so I'm only going to go over this first problem on a set of problems that you sent me. If you want to do the next three, you can send me what answers you got, and I can let you know if they are right or wrong, or I can email you the answers as well before. But I'm only going to go over this one with you. Now, there are other ways that you can go about solving this. It's not just one way that you have to do it. So if you don't like the way I'm going to show you now, then you can go and look on Khan Academy or see if any other videos online that you can find. The way I'm going to show you now, though, could actually be useful for when you get to calculus, because it's this kind of number line test that we're going to do. So the first thing we do is we're going to set this, take one of our sides and move it all over to everything we have is on one side of our inequality. And since this is an easier side just to move, I'm just going to subtract x from both sides. Now I'll get 2 over x minus 1 minus x is less than 0. All right, now I'm going to actually use what you learned in adding or subtracting rational expressions to combine these. So that means I need to have the same denominator. Well, this one has x minus 1. This doesn't have anything, so we'll multiply it by x minus 1 over x minus 1. And that will give me 2 over x minus 1 minus x squared minus x over top of x minus 1. So then we'll distribute the negative sign in. This will become negative. This will become plus. So it becomes negative x squared plus x plus 2 over top of x minus 1. All right, now we're going to go ahead and factor everything that we can. So if this denominator was not already its simplest binomial, you would then go ahead and factor that out. So the first thing I'm going to do is factor out the negative sign. And when I factor out the negative sign, I'll be left with plus. Pause this. Sorry, for some reason that just deleted it. But when we distribute this negative sign, all right, where I was at is we multiplied that in, so that gave me, this became plus, and it was negative, and then this became a plus x, so it gave me negative x squared plus x plus 2 over top of x minus 1. And then we look to factor everything out. So the first thing I'm going to do is factor out the negative sign out of this numerator, and that will give me an x squared and minus x minus 2. And from there, that will factor out to x minus 2 times x plus 1. And it's all over top of x minus 1. Now remember, I wasn't writing this, but all of this is less than 0. Less than 0. All right, then what we do is we take each of these factors in our numerator and our denominator, and we set them all equal to 0. So x minus 2 is equal to 0, x plus 1 is equal to 0, and x minus 1 is equal to 0. And then we get x is equal to 2, negative 1, and 1. So what this does for us is it gives us, on our number line, we will draw a number line next, and we mark these points. So it's negative 1, 1, and 2. So what we do now is this gives us a bunch of different regions, so you can draw this dotted line if you want. You can imagine it's breaking up your x values into separate regions. So here we have one region, 2 regions, 3 regions, and 4 regions. And then what we do is we pick a point from each of those regions and we plug it into this inequality and see, does it hold true or not. Now the good thing about this is, since we have it set to just being less than 0, we don't actually have to do any mathematical computations, but we just check for the numerical value. So what I mean is, let's pick a number. So let's pick negative 2. So when we plug negative 2 into this inequality here, we will get a negative sign that's already there. Hold on, let me just rewrite this in. I don't know why that disappeared. We would get a negative sign that's already there, and then minus 2 will give us another negative sign. And then negative 2 plus 1 will give us another negative sign as well. So then that is all over top of negative 2 minus 1. That gives us another negative. Well, this gives me a positive. And then negative times a positive is negative over negative. So that gives me a positive number. And if it's a positive number, it's impossible for it to be less than 0. So that means this region is not a solution. So we can X out that region. All right, so if you want to and you feel more comfortable by actually plugging it in to get the numerical value and see if it holds true, by all means, you can do that, but you don't actually have to plug in the numbers. You just can worry about the signs. And when you get to calculus, you'll do some tests where you're using the similar things here, where you don't necessarily need to plug in to see the number of values, but you're just checking for the sign. So this is actually pretty good practice for that. And then you pick a number in between here. So let's just say 0. So when we plug it in, remember we start with the negative sign. Let's use a different color to differentiate. We have a negative sign to begin with. Well, 0 minus 2, that will give me another negative. 0 plus 1, that's a positive. And then 0 minus 1 is a negative. Well, this here will multiply to give us a positive sign. So then I know positive times positive is positive over negative will give me a negative overall. So in between this region, negative 1 to 1, since it gave us a true statement, I know that this is part of our solution. And then between 1 and 2, we pick another point. So let's just pick 1.5. And when we plug that in, remember we start with the negative sign regardless. So it's negative. And it's positive 1.5 minus 2. So it gives me a negative. This will give me a positive on the outside. And then positive 1.5 over 1, that gives me a positive. So these two multiply here to give me a positive. So positive times positive is positive over positive, which is still a positive overall number. Once again, it's not less than 0, so we know this region cannot be a solution. And then we will plug in a point here. Let's just pick 3. Let me pick a different color since it's closer to the purple. Let's just pick that. All right, so then when we plug in 3, we have the negative out front. Well, 3 minus 2 gives me a positive number. 3 plus 1 gives me a positive number. 3 minus 1 gives me positive. Well, negative times positive will give me a negative over positive. That's a negative overall. Since that is less than 0, I know that this region works. And then after I do this, this tells me my solution. And since it is, what you should also do is you can also plug in these test regions to see if it includes it or not. You can also, we know that x cannot equal to 1 because this is our denominator. So you can announce that in the beginning, you can do it at the end, but that's part of our domain where x cannot equal to 1 because it'll make our denominator 0. You can plug in 2 and negative 1 to see if it will satisfy and be part of our solutions. But when we plug those in, we would get 2 over top of negative 2, which is negative 1, and that is not less than negative 1, but equal to. And then when we plug in 2, we would get 2 over 1, which is not less than 2, that's equal to. So we know they don't work. There's also another way that you can identify that. It's based on your inequality. If it's equal to, then the boundaries that do not make our denominator equal to 0. So 1 we know can never work because it makes our denominator equal to 0. So the other boundaries, if it's equal to, will most likely be included. But you still want to test them just in case. So then your final answer for here will be, we use parentheses since it cannot include negative 1, but it's negative 1 to positive 1. And then the U means union, or means it's part of our solution as well. And then it will be 2, and it's parentheses because it cannot include it. And then it's to infinity. Since there's no other number to the right of this, it goes to infinity. So that is how you would write this solution. I know that I kind of just wrote that small on the bottom, but that is how you would write this solution. All right, now the pen is not working anymore, so I can't highlight it, but it's this purple down here. Hopefully you can see me circling it with the pen marker, but it's just not writing right now. So that will be your solution. All right, that's going to be the only one I do. If I confuse you, try and send me messages through Remind, and I'll try to clarify where it's at. But just to overall go over it one more time, is you subtract one side to make your inequality to 0, and then you combine and actually add and do the math for your rational expression on the left side of or the right side of your inequality. Then you factor it out, and then when you factor, each one of these factors gives you a number that you will put on your number line, negative 1, 1, 2. So these factors will give us our boundary lines. And then we're going to test points in each of the regions. Now remember, you don't necessarily have to actually know the numerical value. We just test it for the number signs. And the reason why we can do just the number signs is by setting our inequality to 0, we know if it's positive and this is greater than, then it works. If it's positive and it's less than, it doesn't work. So we don't actually need to worry about any number values. Then you test each region to see if they work. And then at the end, you can test each one of these points, or you can then read your inequality to know if they work. But the one, though, that you know has to not work is this 1, because it will give us our domain as equal to 0, our denominator equal to 0, and it's not part of our domain. All right, so try the other problems, and message me any questions you have, but hopefully this helps.